Hello guys, welcome to Lim Gautek's YouTube channel. Today we are going to prove the drive stability formula from halfway. This was a homework given by my lecturer last week, so without further ado, let's see the question. Okay, as you can see here, this is a question on 10th of February. It's a electrical conditioning and control homework. It's about a drive stability formula, and we want to prove this delta omega formula if the below formula is given. So let's start with here. Okay, so when you see this, you might want to spot something special in this equation. So for me, I see that there's a delta omega in every part of this equation. So I would like to use a ODE approach. As you can see here, this is a first order derivative, and here is your target variable, and this is also a equation, a function in terms of your delta omega. Okay, so not in terms of delta omega, but in terms of t anyway, but 0 is 0. Okay, so if you would like to use a first order ODE, what you're gonna do, you're gonna get rid of this j. Okay, so you divide everything by j, you got this 1 over j, the whole bracket, equals to 0. So here is a first order ODE equation, and looks like this. The general ODE equation is something like this, where your y is delta omega in this case, and x is your t in this case. f1x is 1 over j, the whole bracket, and f2 is 0. So we just proceed with a standard procedure with first order ODE. So your ix equals to e power of integration of f1x dx. Okay, so this is equals to e integrate fx, you just sub it inside. Then what is your dx? Dx is dt. Okay, so here your general equation for y is 1 over ix times with integration of ix f2x dx plus c. So here your y is delta omega 1 over ix, which is what? 1 over ix is inverse of this thing, right? So if you integrate these things, as you can see here, your term here is not in anything in terms of this small t, so this is a constant. So integrate a constant, what you get constant small t, right? So this is small t over j times this whole bracket. And then if you see inverse, what is meant by inverse, you put the negative to the index. Okay, so this thing is e to the power negative small t over j, this whole bracket. Okay, so you sub in the ix and f2x here, and you can see your f2x is equal to 0. So if you integrate a 0 thing, what you got? You get a 0. So these things is integrate 0 dt plus c. So this thing is 0. So you got c e to the power negative t over j, this thing. So if you see your equation, what is left? You just left a c, right? And then if you see your equation, the c is delta omega naught. So and there's a t here. So what I can substitute in order to find this t is when p is equal to 0, your delta omega equals to delta omega naught, right? So from here, you got this delta omega naught equals to c e to the power of negative 0 times whole thing, right? So negative 0 is 0, which is also 1. So you got delta omega naught equals to c. And from here, you sub it back into the equation. What you got? You got the final answer. So it's easy, right? Nothing hard here. It's just that you need to use a ODE and then a substitution method down here to find the delta omega naught. Okay, so this was what I submit last week, and it is similar to what we did. Okay, so thank you for watching this video, and hit the subscribe button if you would like to see more engineering and mathematics video in the future. Hope to see you all in the future. Thank you.